All right, we're gonna measure shoulder flexion right now. So the axis is the lateral surface of the acromion process. The stable arm is gonna be mid-trunk, and the moving arm is going to be midline to the humerus. And typical range of motion is 0 to 180 degrees. So I'm gonna have you stick your arm straight out with your thumb up, and then you're gonna go all the way up as high as you possibly can. Alright, so that is 75. Alright, now we're going to be doing shoulder extension. So the axis is going to be on the lateral surface of the acromion process. The stable arm is going to be mid-trunk, and the moving arm is going to be midline of the humerus. And typical range of motion is 0 to 50 degrees. So you're going to go ahead and bring your arm back as far back as you can go. And it is 45 degrees. We're going to measure abduction of the shoulder now. So typical range of motion is 0 to 180. The axis is going to be on the posterior aspect of the acromion process. The stable arm is going to be parallel to the spine, and the moving arm is going to be posterior aspect to the humerus. So you're going to go ahead and bring your arm all the way up as far as you can go. Yep. So normal range is 0 to 180, and you are at 134. We're going to be measuring shoulder horizontal abduction. So the typical range of motion is 0 to 45 degrees, and the axis is on the superior aspect of the acromion process. The stable arm is parallel to the humerus prior to motion, and the moving arm is parallel to the humerus during motion. So go ahead and bring your shoulder back as far back as it can go. So is that far back? All right. You are at 15 degrees. Okay, so we're going to be measuring the range of motion of the elbow flexion. Typical range of motion is 0 to 140 degrees. So the axis is going to be on the lateral epicondyle of the humerus. The moving arm is going to be midline of the radius, and the stable arm is going to be midline of the humerus. So go ahead and flex your elbow. And it is at 145. We're going to be measuring shoulder extension, and the typical range of motion is 140 to 0 degrees. You're going to start at the axis lateral epicondyle of the humerus. The moving arm is going to be midline of the radius, and the stable arm is going to be midline of the humerus. So you're in flex positions. Now go ahead and straighten your arm out. And it is 0. Go. We're going to be measuring wrist flexion. So typical range of motion is 0 to 160 degrees. The axis is going to be on the medial aspect of the ulnar styloid process. The stable arm is going to be midline of the ulna, and moving arm is going to be midline of the fifth metacarpal. So go ahead and flex your wrist. It's going to be 85 degrees. We're going to be measuring wrist extension. And typical range of motion is 0 to 60 degrees. Once again, the medial aspect of the ulnar styloid process is going to be the axis, and the stable arm is going to be midline to the ulna. Moving arm is midline of the fifth metacarpal. So go ahead and extend your wrist. 60 degrees exactly. We're going to be measuring wrist ulnar deviation. Typical range of motion is 0 to 130 degrees. The axis is going to be base of the third metacarpal over the capitate. Stable arm is going to be midline of the forearm, and moving arm is going to be midline of the third metacarpal. So go ahead and deviate. That's at 40 degrees. Okay, we're going to be measuring wrist radial deviation. The typical range of motion is 0 to 120 degrees. 0 to 20, sorry. The axis is going to be the base of the third metacarpal over the capitate. The stable arm is going to be midline of the forearm, and the moving arm is midline of the third metacarpal. So go ahead and radially. And it is at 25. We're going to be measuring MCP flexion. Range of motion of that is going to be 0 to 90 degrees, typical range of motion. And the X is going to be the dorsal surface of the MCP joint of the finger. The stable arm is going to be midline of the dorsal surface of the finger metacarpal, and the moving arm is going to be midline of the dorsal surface of the proximal phalanx of the finger. So go ahead and flex right there, put it into a fist. Go. And it is at 80. Now we're also going to measure the finger flexion of the finger PIP joint. So you're going to start out at 0 here, and the typical range of motion is going to be 0 to 100 degrees. X is going to be on the dorsal surface of the PIP joint of the finger tested. Stable arm is dorsal and midline of proximal phalanx of the finger, and moving arm is dorsal and midline of the middle phalanx of the finger. So go ahead. Typical range of motion is 0 to 100, and we have it at 98. And lastly, we have the flexion of the finger DIP joint. So typical range of motion is going to be 0 to 70 degrees. The axis is going to be the dorsal surface of the DIP joint of the finger tested. Stable arm is dorsal and midline of the middle phalanx of finger tested. The moving arm is dorsal and midline of the distal phalanx of the finger tested. So you're going to go ahead and put your it's at 60. Okay, cut. We're going to be measuring range of motion of the finger MCP extension. Typical range of motion is 90 to 0 degrees, so we're going to start at 90 here. And the axis is the dorsal surface of the MCP joint of the finger. Stable arm is midline of dorsal surface of the metacarpal of the finger, and moving arm is midline of dorsal surface of the proximal phalanx of the finger. So we're going to go ahead and bring it up to 0. There we are. Cut. We're going to be measuring the finger PIP joint extension. Typical range of motion is 100 to 0 degrees, so we're going to start at 100 here, and the axis is the dorsal surface of the PIP joint of the finger tested. Stable arm is the dorsal and midline of the proximal phalanx of the finger, and the moving arm is dorsal and midline of the middle phalanx of the finger. So start at 100, and it's at 0. Cut. Go. We're going to be measuring the finger DIP joint flexion. Range of motion is 0 to 70 typically. The axis is the dorsal surface of the DIP joint of the finger tested. Stable arm is dorsal and midline of the middle phalanx of the finger tested, and moving arm is dorsal and midline of distal phalanx of the finger tested. So we're starting out at 70 degrees, and our goal is to bring it up to 0. And there it is, at 0 degrees. We're going to be measuring range of motion of the thumb MCP joint flexion. So range of motion is 0 to 60 degrees. The axis is going to be the dorsal surface of the thumb MCP joint. The stable arm is midline dorsal surface of the thumb MCP joint, and the moving arm is going to be midline dorsal surface of the proximal phalanx. So go ahead and flex. And it's right at 60 degrees. We're going to be measuring thumb IP joint flexion range of motion. Range of motion is typically 0 to 80 degrees. The axis is the dorsal surface of the thumb IP joint. The stable arm is midline dorsal surface of the proximal phalanx, and the moving arm is midline dorsal surface of the distal phalanx. So go ahead and flex that. And it's at 70 degrees. Cut. We're going to be measuring the thumb CMC joint radial abduction, also known as extension. So the typical range of motion is 0 to 20 degrees. The axis is going to be over the CMC joint at the base of the thumb metacarpal. The stable arm is parallel to the second or index finger metacarpal, and the moving arm is parallel to the first or thumb metacarpal. So go ahead and abduct your thumb. It's at 30 degrees. We're going to be measuring the thumb CMC joint palmar abduction, abduction. Typical range of motion is 0 to 50 degrees. Your axis is going to be over the CMC joint at the base of the thumb metacarpal. The stable arm is parallel to the second or index finger metacarpal, and the moving arm is parallel to the first or thumb metacarpal. So go ahead and it is at 40 degrees. Cut. We're going to attempt to measure the lack of opposition here. So bring your thumb and last finger together. Since there is no lack of opposition, it's going to be 0.